Hello again. My name is Richard and welcome to my YouTube channel. Today, our discussion will still be solving 2018-2019 Valley View University semester examination on Calculus 1. We said this particular examination was divided into two sections, Section A and Section B. In Section A, which carried 40 marks, students were supposed to answer two questions there, which is compulsory. Then Section B, there are 5 questions and students were supposed to answer 3 of them for 60 marks. We have solved the Section A aspect of this examination, and in Section B, we solved the question 3 and the question 4. Please, if you have not watched any of these two videos, check it out on YouTube. Today, before the video will end, we'll solve the question 5, 6, and 7. This will be a very interesting engagement, so please watch the video till the end. Okay, so we start with the question 5A. Before we do that, did you subscribe to my YouTube channel yet? Please do. It is the only way you can help me grow my YouTube channel so that I will record more mathematical content with you. Also remember to share, like, and keep your comments coming. Your comment keeps me going. So now let's go to the question 5A. So we should evaluate the integral of 6x plus 13 all over x squared plus 5x plus 6 dx. And this is worth 8 good marks. So how do we solve this? Please remember, when you differentiate x squared, you get 2x. You don't get anything at the top. So you can't use integration by substitution. It's out. So what you need to do is to solve this using integration by partial fraction. Please check out my videos on YouTube on integration by partial fraction. So now we'll pull out this and resolve this into partial fraction. After that, we integrate. So we can say that we let 6x plus 13 all over x squared plus 5x plus 6 to be equivalent to, when we resolve this, this is quadratic function. When we resolve it, we'll get 6x plus 13 all over x plus 3, then x plus 2. So we can let this to be equivalent to a over x plus 3 plus b over x plus 2. So now, since this is the same as this, we can say 6x plus 13 is equal to this. Or we can resolve this as finding the LCM of this, which is x plus 3, x plus 2. So when x plus 3 divide this, we'll be left with x plus 2. So we'll get a bracket x plus 2 plus b bracket. When this divide this, we'll be left with x plus 3, so plus x plus 3. So since the denominator here is the same as the denominator here, we can say the numerators are equal. So 6x plus 13 will be equal to a bracket x plus 2 plus b bracket x plus 3. And we can solve this using cover up or substitution. So I want to solve this by substitution. First, I'll let x to be equal to negative 2. That's equating this to 0. X will be equal to negative 2. I'll substitute. I'll get 6 times negative 2 plus 13 will be equal to a bracket negative 2 plus 2 plus b bracket negative 2 plus 3. When I do that, 6 times negative 2 will be negative 12 plus 13. Negative 2 plus 2 is 0 times a will be 0. Negative 2 plus 3 is 1 times b will be b. Negative 12 plus 13 is 1 and it will be equal to b. So we can conclude that our b is 1. Also, we let s to be equal to negative 3. That's by equating this to 0. S will be equal to negative 3. We substitute. So we get 6 times negative 3 plus 13 will be equal to a bracket negative 3 plus 2 plus b bracket negative 3 plus 3. So 6 times negative 3, that will be negative 18 plus 13 will be equal to negative 3 plus 2 is negative 1 times A will be negative A. Negative 3 plus 3 is 0 times B will be 0. Negative 18 plus 13 will be negative 5 equal to negative A. So we can say A is equal to 5. Then we can say our partial fraction, which is 6x plus 13 all over x squared plus 5x plus 6. That's 6x plus 13 all over x squared plus 5x plus 6 will be equal to A over x plus 3. And what is our A? Our A is 5. So we can say 5 over x plus 3. Then plus B over x plus 2. And what's our B? Our B is 1. So 1 over x plus 2. So after resolving to partial fraction, we substitute it back. So we can say that our integral of 6x plus 13 all over x squared plus 5x plus 6 dx will be equal to the integral of 5 over x plus 3 plus 1 over x plus 2 dx, which we can further write as 5, the integral of, I'm integrating it 10 by 10, so 5, the integral of 1 over x plus 3 dx plus the integral of 1 over x plus 2 dx. Now remember, when we let x plus 3 to be equal to u, we can integrate this by substitution and we'll get 1 over ln x plus, we'll get ln x plus 3 as the result. And this one will also be ln x plus 2. So we can say the integration of that will be 5 ln absolute value of x plus 3, then plus ln absolute value of x plus 2, then plus our constant of integration. Now remember, in log, when you have this, you can rewrite it as ln absolute value of x plus 3 exponent 5 minus plus ln absolute value of x plus 2, then plus our constant. Remember also, in the law of logarithm, when two logarithms are adding with the same base, we can multiply, and vice versa. So we can say this is ln x plus 3 exponent 5 times x plus 2 plus our constant of integration. Therefore, the integral of 6x plus 13 all over x squared plus 5x plus 6 will be equal to this. I hope you get that. So the B aspect of the question 5, which is worth 12 marks, says that we solve the differential equation x squared dy over dx equal to y bracket y minus 1. So how do we solve that? Please check out my videos on finding solutions to first order separable differential equations on YouTube. So now how do we solve this? We can say that dx squared dy will be equal to y bracket y minus 1 dx. So this is a simple separable first order differential equation. So what do? We need to divide both sides by x squared y bracket y minus 1. When we do that, we get 1 over y minus 1 dy equal to 1 over x dx. So we have separated it easily with dy against the y and a dx against x. So how do we solve this? After separation, we just integrate to solve that. So we can say that we integrate both sides, get 1 over y minus y dy equal to the integral 1 over x dx. Now, okay, square, x square. Please, there is square here, so x square. Now, we can easily integrate this. What of this? You can't just easily integrate this. We need to pull out this and use integration by partial and resolve this into partial fraction. After that, we integrate. So now let's learn how to resolve this into partial fraction. So we can say that our 1 over y bracket y minus 1 will be equivalent to a over y plus b over y minus 1, which can be a, we find the denominator there, which is y minus 1. When y divide this, we're left with y minus 1, so it will multiply the a, then plus b. When this divide this, we'll be left with y, so it will multiply the b. So now the denominator here is the same as this one. So we can say we equate the numerator. So 1 will be equal to a bracket y minus 1 plus b bracket y. So we let y to be equal to 0. When y is equal to 0, you can say 1 is equal to a times 0 minus 1 plus b times 0. So 1 will be equal to 0 minus 1 will be minus 1 times a will be minus a. B times 0 is 0. Then we can say a is equal to minus 1. In the same vein, we let y to be equal to 1. That's by equating this to 0. So our 1 will be equal to a 1 minus 1 plus b times 1. So 1 will be equal to 1 minus 1 is 0 times a will be 0, then b times 1 will be b. Then you can say our b is equal to 1. So a is minus 1, b is equal to 1. We substitute it here. So we can say that our 1 over y minus 1 will be equivalent to a, which is minus 1 over y, plus b, which is 1 over y minus 1, which we can rewrite as y minus 1 equal to 1 over y minus 1 minus 1 over y. I'll write this one first, then the other one. It doesn't change the meaning of it. So now we know this to be that. We substitute into each place here before we integrate. So we can say the integral of 1 over y minus 1 will be the integral of 1 over y minus 1 minus 1 over y dy equal to the integral of, we can rewrite this as s exponent negative 2 dx. So we integrate this 10 by 10. Can get the integral of 1 over y minus 1 dy minus the integral of 1 over y dy equal to the integral of s exponent negative 2 dx. So we integrate this. We get ln absolute value of y minus 1 minus ln absolute value of y plus our constant of integration. You can bring it here too. It's the same. Equal to. Now remember integration rule. We add 1 to that and divide the function by the result. So we get negative 1 over x. Now, in logarithms, when two logs are subtracting, we can divide. So we can get ln absolute value of y minus 1 over absolute value of y plus c is equal to negative 1 over x. So this c is constant 1, 2, 3, 4. So we can let it be equal to another constant. So we can say let c to be equal to ln k. So when we say that, we can say now that ln absolute value of y minus 1 over ln y plus ln k is equal to negative 1 over x. So when two logarithms are also adding with the same base, we can multiply. Then we can say this is ln k times y minus 1 over y is equal to negative 1 over x. Remember, lns are logs with natural base e. So we can say this is k y minus 1 over y is equal to e exponent negative 1 over x. That property of log. So you can set k bracket y minus 1 will be equal to y e exponent negative 1 over s as our final answer. This is worth 12 marks. Okay, so we'll go to the question 6 and we'll look at the A aspect, which is worth 7 good marks. Says that consider the function g of s equal to s cubed minus 1 over s minus 1 if s is not equal to 1 and g of s is equal to 2 when s is equal to 1. Now show whether or not g of s is continuous at x equal to 1. So this is on continuity of a function. So a function is said to be continuous at a particular point if the outcome of that point, of that point in the function is equal to the limit of the function where x approaches that point. So what is the meaning? We say that the function g of s is said to be continuous at s equal to 1 if only and only if g of 1 is equal to the limit where x approaches 1 of g of x. So when we find this and they are equal, then we say the function is continuous at that point. If they are not, then it is discontinuous at that point or not continuous. So now we'll find g of 1. Remember, x is equal to 1 there. Then we can say g of 1. Since s is equal to 1, we can say g of 1 is 2. Very simple. Now we'll find the limit where the limit of g of s where s approaches 1. So when s approaches 1, it's either approaching it from the left or from the right. So we can't vividly say it is equal to 1. So it will not be equal. Then we can take when g of s is s cubed minus 1 over s minus 1. So we can say we have the limit of s cubed minus 1 over s minus 1 where s approaches 1. Now when we substitute 1 here, you see that we are going to get 0. So what do? We use L'Hopital, which says that we differentiate the top differently, differentiate the down differently, then we substitute. So this will be equal to the limit. When we differentiate this, we'll get 3x squared. We differentiate 1, we'll get 0. Over. When we differentiate x, we'll get 1. Then we differentiate that one, we'll get 0, where x approaches 1. So this can simply be the limit 3x squared where s approaches 1. So now we substitute that. So we'll say that will be 3, in place of x we substitute 1 square. So that will be 3. So we realize that the g of 1 is 2. And the limit of g of s where s approaches 1 is 3. They are not equal. So we can say that our g of 1, which is equal to 2, is not equal to the limit where x approaches 1 of g of x. And that one is 3. So therefore, the function g of s is not continuous or is discontinuous. It's not continuous at s equal to 1. I hope you get that. Okay, so the B aspect of the question 5, which says that we shall evaluate the integral of e exponent at sine 80 dt, which is worth 12 marks. The first one was worth 8 marks. So how do we solve this? See, remember, when we differentiate e exponent 80, we'll get a e exponent 80. We won't get sine 80. Also, when we differentiate sine 80, we'll get a cos 80. We won't get e exponent 80. So you need to solve this using integration by part. You can't use integration by substitution. So now, by integration by part, we let u to be equal to e exponent 80. Then dv over dt to be equal to sine 80. Now our du over dt, remember that we just differentiate this and use it to multiply. Remember the a is constant. So when we differentiate this, we get a e exponent 80. Now to solve this, we need v, so we need to integrate. So what's the integration rule? The integration rule states that differentiate this. After that, integrate sine. When we integrate sine, we get negative cos. Repeat the angle 80. Then use the differential to divide a. So now we know the necessary thing. Then we can say that by integration by part, the integral of u dv over dt is equal to uv minus the integral of v du over dt. Now, what's our u? Our u is e exponent 80. dv over dt is sine t. So we can say that the integral of e exponent 80 sine 80 dt will be equal to u, which is e exponent 80, then v, which is negative cos 80 over a. Then minus the integral of v, which is negative cos 80 over a times du over dt, which is a e exponent 80 dt. We can polish this further. You can say the integral of e exponent 80 sine 80 dt will be equal to negative e exponent 80 cos 80 over a plus the integral of, see, this a can divide that a, so we'll be left with e exponent 80 cos 80 dt. Now what is this? Another integration by part pops out again. So we need to solve this by part. After that, we substitute. So another integration by part came out. Please, this is question 6b. The first one was question 6a. So now we need to solve this by part. Again, let u to be equal to e exponent 80 and dv over dt to be equal to cos 80. When we differentiate this, that's the u over dt, we'll get a e exponent 80. And when we integrate this to get v will be equal to sine 80 over a. Now remember integration by part, which says that the integral of u dv over dt is equal to uv minus the integral of v du over dt. Now what's our u? Our u is e exponent 80 and dv over dt is sine, dv over dt is cos 80. So we can say e exponent 80 cos 80 dt is equal to, what's u? U is e exponent 80 and v is sine 80 over a minus the integral of v, which is sine 80 over a times du over dt, which is a e exponent 80 dt. Now we'll polish this further. We'll get the integral of e exponent 80 cos 80 dt equal to e exponent 80 sine 80 over a. Then this a will divide that a. So we'll get minus the integral of e exponent 80 sine 80 dt. So now, we know the integral of e exponent 80 cos 80 dt to be this. We substitute it in this place. So, now we can substitute this in place of integral of e exponent 80 cos 80 dt here. So we can say that the integral of e exponent 80 sine 80 dt will be equal to negative e exponent 80 cos 80 over a. Then in place of this, we substitute this. So plus e exponent 80 sine 80 over a minus the integral of e exponent 80 sine 80 dt. Now, remember in integration by part, anytime you are solving by part, what you are integrating by part pulls out again. There is no need to integrate by part. We just bring them together. So we can transfer this to this. So we'll get the integral of e exponent 80 sine 80 dt plus the integral of e exponent 80 sine 80 dt. Then I want to write this one first, since this is negative. Will be equal to e exponent 80 sine 80 over a minus e exponent 80 cos 80 over a. Now this plus this will just be 2. So 2, the integral of e exponent 80 sine 80 dt will be equal to a, and e exponent 80 is common. So I can say e exponent 80 over a times sine 80 minus cos 80. Now I'll divide both sides by 2. So I can say the integral of e exponent 80 sine 80 dt will be equal to e exponent 80 over a times sine 80 minus cos 80 divided by 2. So remember, this 2 is over 1. I will just multiply and reciprocate. You can say the integral of e exponent 80 sine 80 dt will be equal to e exponent 80 over a times sine 80 minus cos 80, then times 1 out of 2. So when this multiply this, we'll get e exponent 80 over 2a. So we can say that the integral of e exponent 80 sine 80 dt, which they are asking us to evaluate, will be equal to e exponent 80 over 2a times sine 80 minus cos 80, then plus our constant of integration. This is worth 12 marks, so expect it to be long. I hope you get it. So we'll solve our last aspect of the section B, which is question 7. And we start with the A. We say we should evaluate the integral of x, the square root of x squared minus 1 ds. And that was worth 7 marks. Now look at it. When we differentiate s squared, you get 2x. That's a linear expression as x is popping out. Then you can solve this using integration by integration by substitution. So we can say the integral of x, the square root of x squared minus 1 dx can be rewritten as the integral of the square root of x squared minus 1 x dx, and it will not change the meaning of it. We can rewrite this as the integral of x squared minus 1 exponent half x dx. You know, the square root of any number is that number exponent half. So now let u to be equal to the x squared minus 1. Then our du over dx will be equal to 2x. So we can say that du is equal to 2x dx. That's multiplying both sides by dx. Then we can divide both sides by 2. Our du over 2 will be equal to x dx. So we can say our integral of x squared minus 1 exponent half x dx will now be equivalent to the integral of now x squared minus 1 is u. So in place of x squared minus 1, we substitute u. So get u exponent half. Then our x dx is du over 2. So that will be du over 2. Which we can rewrite as half. We can put the half out. The integral of u exponent half du. Now remember integration rule. We add 1 to the exponent and divide the function by that result. So we can say that will be half u exponent half plus 1 all over half plus 1 plus our constant of integration. Now we get half plus 1 is 3 out of 2 over 3 out of 2 plus c. Now since this is divided, we can multiply and reciprocate. We can say this is half times 2 out of 3 u exponent 3 over 2 plus our constant. When this multiply this, we get 1/3. Then we can rewrite this as the square root of u exponent 3 using indices plus constant. Now remember, our u is x squared minus 1. So now we substitute. So when we substitute our u there, we'll get 1/3 the square root of, in place of u, we substitute x squared minus 1. So x squared minus 1 cube plus our constant of integration. Then we can conclude that the integral of x, the square root of x squared minus 1 dx will be equal to 1/3 bracket the square root of x squared minus 1 cube plus our constant of integration. I hope you get that. We go to the B aspect of question 7. So the B aspect of the question 7, which says that find dy over dx if y is equal to cosec x, and that is worth 5 marks. So if y is equal to cosec x, remember cosec is the inverse of sine. And we can say this is the same as 1 over sine x. So how do we solve this? Since this involves fraction, we can use quotient rule to solve that. So let u to be equal to 1 and v to be equal to sine x. So how do we solve this? We'll find du over dx. Du over dx will be 0. Remember the differentiation of constants. Now our dv over dx will be equal to cos x. Remember from quotient, our dy over dx will be equal to v du over dx minus u dv over dx all over v square. Now this implies that what's our v? V is sine x. So sine x and d over ds is 0. So times 0 minus u, which is 1, times dv over ds, which is cos s, all over v square, and v is sine s, so sine square s. So we can say our dy over dx will be equal to sine times 0 is 0, negative 1 times that will be negative cos x over sine square x, which we can rewrite as negative cos s over sine x times 1 over sine x. Or we'll multiply this, we'll get this back. Remember, sine s over cos s is tan. But since we haven't cos s over sine s, that will be the inverse of tan. And what is the inverse of tan? The inverse of tan is cot. So we can say this is negative cot x. And 1 over sine s, we said from the beginning, is cosec. So that will be cosec x. So we can say that our dy over dx finally will be equal to negative cot x cosec s if y is equal to cosec s. I hope you get that. So we'll solve the last aspect of the section B, which is question 7c, worth 8 marks. So we should find dy over dx if y is equal to ln bracket x over the square root of x squared plus 1. And this is worth 8 marks. Please, before we do that, remember to subscribe to my YouTube channel. This will make my YouTube channel grow more and I can record more mathematical content for you. So now we solve this. Remember, if we have y is equal to ln bracket x over the square root of x squared plus 1. In differentiating ln functions, we say that you reciprocate this. You differentiate and use it to multiply. However, when you try doing that, this will be very difficult for you. But we can rewrite this function using the laws of logarithm, which says that if two logarithms are dividing with the same base, we can subtract them. So we can say this is ln x minus ln the square root of x squared plus 1. So we can rewrite that as y is equal to ln x minus ln x squared plus 1 exponent half. So now to differentiate, we differentiate this term by term using the law of differentiating logarithmic functions. Please check out my videos on how to differentiate logarithmic functions on YouTube. So we can say that our dy over dx is equal to this. So we reciprocate this 1 over x. We differentiate this 1. When we use it to multiply, we still get the same thing. Minus, we reciprocate this 1 over x squared plus 1 exponent half. Now we differentiate and use it to multiply. So remember, to differentiate, you need to use chain rule, but you can differentiate this directly with that chain rule. Check out my video on how to integrate and differentiate directly without using chain rule. You drop the power first, half. You differentiate what is in the bracket. When you differentiate, you get 2x. We differentiate this, we get 0. Repeat the base again. Now you subtract 1 from the exponent, negative half. Now let's polish this. We can say our dy over dx is equal to 1 over x minus. Now when 2 multiply, half multiply 2x, we'll be left with x there. So we can say the top will be x bracket x squared plus 1 exponent negative half over x squared plus 1 exponent half. Remember, we can drop this using the law of indices. We drop this to kind of multiply this, and this will change to positive. So you can say dy over dx is equal to 1 over x minus x over x squared plus 1 exponent half times x squared plus 1 exponent half. And remember, these are multiplying with the same base. We use indices, we add the exponent. And half plus half is 1. So we can say dy over ds is equal to 1 over x minus x over x squared plus 1. So we can solve this further by finding the LCM here. We can say our dy over ds is equal to, the LCM will be x squared plus 1. So if x divide this, we'll be left with x squared plus 1 times 1 will just be x squared plus 1. Then minus, when this divided, we'll be left with x times x will be x squared. So on polish that further, we can say our dy over ds will be equal to x squared plus 1 minus x squared all over x squared plus 1. So x squared minus x squared is equal to 0. So we'll be left with 1 all over x squared plus 1. And that becomes our dy over ds. So it is equal to 1 over x squared plus 1. So that is the end. Please remember, the proper way of preparing for an examination is solving past questions. So as you watch the video, try to pause it and solve these questions and get prepared well before you write your examination. Remember to subscribe to my YouTube channel as I said earlier. Until we meet again, my name is Teteje Kepsi Richard.